Welcome to 6.3 Arithmetic with Rational Functions. Today we will be experimenting with rational functions and arithmetic, so plus, minus, times, and divide. So if you want to multiply and divide rational functions, you do it just like if you would to multiply and divide regular numbers. A over b times c over d equals ac over bd. So we're going to multiply these two functions right now. 5x squared multiplied by 4y over 2y multiplied by 2x is 20x squared y over 4xy. And 20 divided by 4 is 5. The y's cancel off. And the x squared divided by x squared divided by x is equal to x2 minus 1, which is just x1. 5x is the answer. So we're going to do another practice. 3x squared y minus 3 over 25x times 5x over 3y. So let's multiply 3x squared y 3 minus 3 times 5x. So 3x squared y minus 3 multiplied by 5x over 25x multiplied by 3y. So the x squared and the x combine together to make x to the third, and 3 times 5 is 15, so 15x to the third, and then this y negative 3 actually goes at the bottom because y negative 3 is equal to 1 over y cubed. So 25 times 3 is 75. We have x, and then y, and then y3. But this y3 can combine with this y1. So, and this x cubed and this x can also be taken away. So we have 15x squared over y times y3 is y to the 4th power. And 15 over 75 is 1 over 5. So the answer is x squared over 5y to the 4th power. Okay, x squared over 5y to the 4th power. Yeah, okay. So if you multiply non-monomials, whenever you are multiplying numbers that are not monomials, you should find a factor that both the top and the bottom has, so that you can eliminate them. So let's do some practice. X squared minus x minus 6 over 4x cubed times 2x squared plus 2x over x squared plus 5x plus 6. So let's factor. So x squared minus x minus 6. Factoring. You guys can do that in your head. You guys can do that factoring on paper, but I'm gonna do it in my head. There you go. Times 4x cubed multiplied by 2x looks like x plus 1, then x plus 2, x plus 3. Okay, so x plus 2 and x plus 2 crosses off. 2x here and 4x cubed crosses off. 4 divided by 2 is 2, and x cubed divided by x is x squared. There you go. So your final answer is equal to x minus 3 multiplied by x plus 1 over 2x squared x plus 3. That is your final answer. You could simplify that. You could make it. You could expand that to x squared minus 2x minus 3 over 2x cubed plus 6x squared. But there's no point, in my opinion. So number 19. I'll give you 5 seconds to do it by yourself. 5, 4, 3, 2, 1. Okay. Now I'm gonna do it. So the top factors out to x plus 9, x minus 4. The bottom factors out. This is the difference of two squares. So x squared minus 49 is x squared minus 7 squared. So it's x plus 7. You have to remember this formula. X squared minus y squared equals x plus y, x minus y. X squared minus 7 squared, x plus 7, x minus 7. Multiply all that by factoring that, you'll get x minus 4 times x minus 7. So cross that off, and then your final answer is x plus 4 squared, no, x minus 4 squared. Oops, sorry. Actually, I'll just put x plus 9. X plus 9, x minus 4 squared over x plus 7. There you go. So dividing rational functions, the process is the exact same process, except you flip the second fraction, then you multiply. So we're going to do this critical thinking. Find the expression that makes the following statement true. Assume that x is not equal to negative 2, x is not equal to 5. So let's do this. So if this is true, then whenever you flip this, x minus 5 over x squared plus 2x minus 35, whenever you flip this and then you change it to a multiplied sign, x squared minus 3x minus 10 over whatever this box is equals x plus 2 over x plus 7. So gotta figure out what that box is. So we're gonna factor. Right, you always factor. So x minus 5, x squared plus 2x minus 35 is x plus 7 times x minus 5. So there you go, your x minus 5 is already crossed out. Multiply that by x squared minus 3x minus 10, which is x minus 5, x plus 2. And then this box right here equals, I'm going to move this a little bit, move this over here, equals x plus 2 over x plus 7. So if you notice right here, there's already an x plus 7 down here. So we don't really need to multiply anything else over here, because there's already an x plus 7. There's already an x plus 2 on the top. So we don't really need to multiply by anything else. However, there's this obstructing x minus 5 right here that needs to be removed. So how do we remove this x minus 5 that needs to be removed? We put x minus 5 at the bottom. Because if you put x minus 5 at the bottom, it cancels out. Then you'll get x plus 2 and x plus 7. So the box is x minus 5. That's what the box is. Because if you don't put, if it's not x minus 5, you'll get x minus 5, x plus 2, x plus 7, and x something else, and then it will be a mess. So you gotta erase what you don't need by putting it on the opposite side. Yeah, erase what you don't need by putting it on the opposite side. Okay, next, adding and subtracting. Adding and subtracting these rational functions are a little bit confusing. So here we go. First of all, you factor the denominator if they're quadratics. If they're not quadratics, you don't factor them, but you factor them, right, to their most factored form without going into the imaginaries. And then you see which ones are the same. So this one, for example, x minus 2 and x minus 2, they're the same on both sides, right? See which ones are the same. But you take the one that's not the same on each side. So for example, x plus 3 right here. And then you multiply it to the other side. So x plus 3 is not the same on this side. You multiply it to this side. X plus 3 over x plus 3. X plus 3, x plus 3. Right? And then you take this x minus 6 right here. This is not over on the other side. So then you multiply it to the other side as well. So now you have x minus 6, x minus 6. And I am sorry, there is a mistake right here. It is supposed to be x minus 2 in here as well. X minus 2 in here as well. And this is not the correct answer. I'm just not going to simplify it. Okay. But that's basically it. So you take one of the sides, you move it to the other side, you take the one that's not the same on both sides, and you move it to the other side. If there's 3 fractions, you take the one that's, if it's the same on 2 of them, then you multiply it once on the one that's different. For example, if there's an x minus 6, and x minus 2, on the x minus 2, you want an x minus 6. And on the 2 x minus 6's, you want an x minus 2. So basically, you want every single one to have all of the factors at the bottom. So let's do some practice. Actually, before we do some practice, this is a property. A property is or like a postulate is something that works because it just works. That's what it is, and it's been proven to work. So for example, I'm gonna prove this real quick. A plus b over c plus d is equal to a. So first of all, what does this not have? It doesn't have d. It doesn't have d. So we gotta multiply it by d. So d over d multiply, right? And then what does this not have? It doesn't have b. So we gotta multiply it by b. Only the bottom counts, right? The top doesn't really matter. Okay, so now we have AD over BD plus BC over BD. And then you combine them together because they have the same denominator. AD over BC, AD plus BC over BD. So A over B plus C over D is equal to AD plus BC over BD. So we can use this property for every single fraction with only 2 fractions in it. So a plus b, c plus d. So we have this multiplied by this, 3x plus 2 multiplied by negative 2x minus 2, right? Okay, let me move this a little bit to this side, and then add that to 3x multiplied by 5x minus 6, divide all of that by 5x minus 6, multiplied by negative 2x minus 2, which will get you negative 6x squared minus 10x minus 4 plus 15x squared minus 18x over minus 10x squared plus 2x plus 12, which will get you minus 6x squared plus 5x squared. This is very boring. No, it will not get you minus 6x squared. I am sorry. It will get you 9x squared minus 28x minus 10 over minus 10x squared plus 2x plus 12. And you can factor the 2 out and maybe factor the top. That looks like a factorable top, but I don't think it's factorable. So that's it. Oh, no, that's not it. We have one more question. So this is the test right here. So 24 x squared minus 5 over x squared plus 5x minus 14 minus x plus 3 over x plus 7. So we have x squared minus 5 over x. I'm going to factor this, x plus 7, x minus 2, right, minus x plus 3 over x plus 7. Notice what this side doesn't have. It doesn't have the x minus 2. What does this side not have from the other fraction? It has everything, so you don't have to multiply anything. You can just multiply by 1 over 1. You don't have to multiply by anything because it has everything, right? So we're going to multiply by x minus 2 on both sides, right? So x plus 3 times x minus 2 is x plus 3 times x minus 2 is x squared minus x minus 6. No, plus x minus 6, right? And remember, there's a minus here, so we have to do this. And x squared minus 5 here. All of this is over x plus 7, x minus 2, or x squared plus 5x minus 14. So x squared minus x squared is 0. Minus 5 minus minus 6 is 1. and minus x is just minus x. So minus x plus 1, or 1 minus x, over x squared plus 5x minus 14, and that is the answer. That's going to be it for today's episode. If you want more course suggestions, I know I've been really late on the world history first course, but I'm making it right now. You could see right here, world history 1.1. I'm trying to make a world history course. I'm starting one. So and be on the lookout for another course, because I'm going to help all of you in science next. So look out for that. If you enjoyed, press the like button, subscribe, recommend everything, and see you guys next time.